My name is Mario and I'll be demonstrating the demo. First, the patient fills out the form and they start the application by clicking Run. Once it starts, a database is created or opened and a new table is created using the user's information. At the same time, the accelerometer starts recording the X, Y, Z values of the phone. We can move the emulator around to record different values. These values are stored in the table and plotted in the graph view. The users can stop the program by clicking the stop button and the graph view will be cleared. The database is stored in the SD card path. We can download and view the file to verify that the data is stored. As you can see, we are storing the timestamp, the X, Y, Z values of the accelerometer. The users have the option of downloading or uploading the database to a server. For uploading the database, we are running a local server, and once the user clicks the upload button, the database will be uploaded to the server. For the download functionality, I will delete the database stored in the emulator and re-download the file from the server. So by clicking the download database button, the database will be returned. And then lastly, we are graphing the last 10 records from the specific patient's table to the graph view. My name is Mario and I'll be explaining the upload functionality of the app. So once the upload button is clicked, we save the path, the file name, and the server address of the upload.php file. The upload.php file is just a simple file that will move the uploaded file to a new location. We create a new thread and run the upload file function, which accepts a path, a file name, a server address. We locate the file using the .get external storage directory. We convert that file into an input stream, convert that input stream into a byte array called data file. We create an HTTP client and a post. We create an input stream body from the data file and the file name. We create a multi-part entity, pass in the file which is the same as the upload.php and the input stream body. We set that multi-part entity into the HTTP post, and then we pass in the HTTP post into the HTTP client, and then we get a response.
My name is An Nguyen and I implemented the download task. Firstly, we create a new class with two inputs. The first input is the source address because in this assignment we create a local server. So if you use one of these address, you should use the first input in this address in order the emulator can access the local server, and the second input is the location where you want to store the SQL file, and we choose SD card to store the SQL file. Then you will use the HTTP or HTTPS protocol to download the file. Secondly, you go to the database class to do a query SQL. You will get the XYZ access information from the user of the database file you downloaded. And then after you get the information from the SQL file, you will create three objects which associated with the XYZ information. You will pass on the object to the graph view to show on the screen.
I'm Vipanchi and I'm going to talk about the database. So when the onClick listener is called, we call the create table function. This create table function calls the DB handler and we send the main activity as an object. In this, we create the column names and then we call the set table name function. Here we take the name, ID, age and sex as the table name. We create the create table function, and here to send the SQL command as string, we send the ID, timestamp and XYZ values, commit it and then end the transaction. In the main activity, we have a sensor event listener. So here we call the add entry xyz function. What this function does is it limits the points to 10. So once that is done, after calling the add new db entry, we call the insert new data, sending these xyz values. Insert new data, we open the db, we then take the xyz values and place it according to the column names. In the download button, we create the table name and then we take an array list and then we call the get data from current patient function. In this function, we select the XYZ values from the table name ordered by timestamp and then we put all the XYZ values into a list and then send it back. Once we get the array list, we take the series XYZ and place XYZ values in this. And then we start the graph.
My name is Efren Lopez and I implemented the graph view and the accelerometer sensor. So first I'm going to talk about the sensor. So here I declare a new sensor accelerometer. Then here I use the sensor manager to get information from the sensor. Then here in this sensor event listener, this is the most interesting part where we actually collect the data. So every time there is a change, we will get the X, Y, and Z axis from the values of this sensor. And then we add this to the add entry function. And this add entry method, it's here, and here you can see how we are storing the data. So the graph view, so this is the add entry that I talked about before. So in this entry, we add a maximum of 10 points, and then we scroll till the end of the graph. Then you have the star graph. So here you can see how the series are being actually drawn in the graph, blue, green, and red colors for different colors for each axis. And here in stop graph, you see how they are actually being removed.